Welcome to INSITECT. Today we are talking about cloud solutions, infrastructure, security, and deployment models.
It really is the essential discussion for any enterprise CTO right now. We're so far beyond just renting servers. What we're witnessing is a complete transformation of the computing landscape.
Exactly. It's this move away from managing huge capital expenses, your CapEx for hardware you bought years ago.
Hardware you hoped you'd eventually use, right?
Yeah, exactly. And our mission in this deep dive is to really cut through the complexity and look at the fundamental architecture. The real story here, I think, is financial agility. It's about turning those high fixed costs, that CapEx,
Into nimble, variable operational costs,
Right.
OpEx.
Right.
And let's put a practical definition on that. CapEx is spending $10 million upfront on servers that might sit idle 80% of the time.
Mm-hmm.
OpEx is spending, say, $20,000 this month, and if your product suddenly takes off tomorrow, you just scale up. No need to call the CFO, no need to buy a single new piece of physical hardware.
That speed, that velocity is the whole selling point. And the engine behind it all is, of course, virtualization.
That's the magic trick. It's what abstracts the physical server resources, letting you run multiple, totally isolated environments on the exact same piece of metal. No interference.
And it all relies on these massive centralized data centers with redundant power, redundant cooling, everything you need to guarantee that continuous operation we're all paying for.
Absolutely. And what's so fascinating is that every single decision you make, technical, financial, it all comes down to where you decide to draw the line of responsibility.
Which brings us straight to the service models. Because this layered architecture is what defines where the provider's job ends.
And where your job begins. It is literally a spectrum of control.
So let's start at one end. If you need maximum flexibility, maybe for a lift and shift migration of an older app, you're looking at infrastructure as a service,
Right.
or IaaS.
Exactly. The provider manages the absolute core, the physical hardware, the hypervisor layer, but you, the customer, you own everything else, the operating systems, the applications.
And you get that immediate benefit of pay-as-you-go pricing, which is perfect for workloads that, spike unexpectedly.
It is, but managing the OS yourself is still a heavy lift, isn't it? It slows you down.
It absolutely does.
Uh,
And that's why we're seeing this huge gravitational pull toward platform as a service, or PaaS.
mm-hmm. Here, the provider steps up another level. They manage the OS and the middleware, so your developers. They can just focus on writing code and shipping features.
Which means things like automatic scaling and load balancing just happen. No manual configuration. The development speed just jumps.
But there's a trade-off. It's a critical point. You are now much more tightly coupled to that specific vendor's platform. You're trading some flexibility for that speed.
A necessary trade-off for many. And then, at the far end of the spectrum, you have software as a service.
No.
Email, your CRM. You're subscribing to a fully managed application. The provider handles literally everything, and you just get a predictable bill at the end of the month. Zero operational overhead. So it's a simple rule. High up the stack with SaaS means low control, low management burden. Down at IaaS, you get maximum control, but also the maximum headache.
Speaking of control, that's the perfect pivot to deployment models, because this is where cost control and compliance really start to clash.
Okay, so the default for most new companies is the public cloud. It's driven by incredible economies of scale. But how do they keep it all secure when everything is shared?
It all comes down to logical isolation. The security model is built on hypervisors and virtual networks. There's no physical wall between your data and the customer next door.
And that lack of a physical wall is what pushes larger, more regulated organizations toward a private cloud.
For sure. They need total data control, often because of strict regulations, data sovereignty rules.
And it's not just compliance, is it? It's also about performance.
Yeah, dedicated hardware eliminates that nagging fear of the noisy neighbor, where some other customer's huge job suddenly hogs all the resources and your app slows to a crawl. If you need predictable performance, private is often the only way to go.
Okay, but this is where I think the analyst community is starting to get a bit skeptical. The talk about hybrid and multi-cloud.
Well, hybrid makes a lot of strategic sense, right? You use encrypted tunnels to link your private environment to a public cloud. Keep the sensitive stuff on-prem, but burst out to the public cloud for demand spikes. That's smart.
But multi-cloud, that's a different beast. It's often sold as this great defense against vendor lock-in.
Right. The idea that if you use 3 different vendors, you have more negotiating power. But the research is pretty clear. Doing that significantly, almost exponentially, increases your operational complexity and security risk.
And is vendor lock-in really the boogeyman it was a decade ago? I mean, if one vendor has the absolute best-in-class AI service you need.
Then chasing multi-cloud just forces your teams to maintain expertise across totally different billing models, security tools, APIs. The complexity often just isn't worth it.
You end up matching the speed of scaling with the speed of potential misconfigurations.
That's it exactly.
Okay, so that complexity is critical. Let's drill down into the engine under the hood, because the choice isn't just IS versus PIs anymore. It's about the compute unit itself.
And we have a clear hierarchy here in terms of efficiency. At the base level, you still have virtual machines, or VMs.
The classic. They emulate a complete computer.
Right. They're deeply isolated because they have their own OS, but they're also the least efficient. They're the slowest to boot up.
So then we jump to containers, which are a huge shift.
A massive shift. They share the host operating system's kernel. That's why they're so much faster and more efficient. They just package up the application and its dependencies.
Making them super portable.
Incredibly portable. And the orchestration, how you deploy and scale thousands of them, that's all handled by Kubernetes. It's become the de facto standard.
And then, at the highest level of abstraction, we have serverless, or functions.
This is where you don't even think about a server, an OS, or a container. Your code just executes. It can spin up from 0 to thousands of instances automatically.
Perfect for something sporadic, like processing an image upload.
Exactly, an event-driven workload. You pay literally for the milliseconds your code is running, and that's it.
Okay, so beyond compute, we have to talk storage, because data durability is everything.
It's non-negotiable, and we see two main types. First, object storage.
This is for massive, unstructured data. Think data lakes, media libraries, backups, and the durability claims are just almost unbelievable.
It's the famous 11 nines of durability. And what that actually means, for you listening, is if you store 10 million files, you could expect to lose, on average, just one of them every 10,000 years.
How is that even possible?
Through built-in automatic replication across multiple geographically separate facilities, you access it with simple HTTP APIs, like you're pulling a file from a website.
But that's not what you'd use for a high transaction database, right? For that, you need low latency.
No, for that you need block storage. It provides those persistent volumes, usually backed by super fast SSDs, that give you the raw input-output performance a database absolutely requires.
Got it. And connecting all this is the networking. Virtual private clouds, VPCs, they essentially let you build your own isolated network segment in the cloud.
Mm-hmm. And you secure it at two layers. First, you have security groups. Think of them as a stateful firewall for one specific instance, like one VM.
And then for the bigger perimeter.
You have network ACL's access control lists. They're stateless, but they protect the entire subnet boundary. They're your first line of defense at the network level.
And big companies, they often just bypass the public internet altogether for this stuff.
They do. They use dedicated physical link services like Direct Connect to get a guaranteed low-latency private connection straight into the cloud provider's network.
This whole discussion on the plumbing, it leads us right into the security deep dive. And the framework that underpinned it all. The shared responsibility model.
Before we even get to that model, we have to start with identity. Identity and access management, IAM, is the absolute foundation. We're seeing strict, mandatory adherence to the principle of least privilege.
Meaning you grant the absolute minimum permissions needed for a job and nothing more.
Right. To minimize the blast radius if, or more likely, when a credential gets compromised.
And credentials will be compromised.
Right.
Which is why multi-factor authentication is just.
Yeah.
It's not a suggestion anymore. It's a baseline engineering requirement.
A password alone is basically meaningless now. Then, for data protection, everything is encrypted. At rest, it's AES 256. But more and more, we see organizations choosing customer-managed keys.
So they have greater control and an audit trail over the whole encryption lifecycle.
Exactly. And for the highest level of security, for those master keys, you use a hardware security module, an HSM, a tamper-resistant physical device designed for one thing, protecting cryptographic keys.
And the providers back all this up with certifications, right? ISO 27001, SOC2, HIPAA.
They do, and those certifications prove that the infrastructure, the physical data center, the hypervisor, is secure.
But this is the key distinction, isn't it? That security of the cloud. The customer is still 100% responsible for security in the cloud.
It is the most critical, non-negotiable distinction. The vast majority of breaches we investigate are not the provider's fault. They're customer misconfigurations. A storage bucket left open to the world, a firewall rule that's way too permissive.
And the audit logs are what provide that immutable trail to figure out what went wrong.
They are. Misconfiguration is the real enemy here.
Which leads us straight into operations and how automation is the only way to keep the cloud both secure and cost-effective.
It starts with cost. You have cost explorers to track spending, but the real savings come from reserved commitments for your steady workloads.
And from aggressive right-sizing. We still see so much waste from teams spinning up a huge server when a tiny one would do the job.
It's just identifying that over-provisioning is pure, immediate savings. But the real game changer for stability is infrastructure as code, ISC.
Let's give that the weight it deserves.
Yeah.
IAC is foundational. It's the difference between a chef just eyeballing ingredients versus having a precise, version-controlled recipe that anyone can execute flawlessly every time.
That's a perfect analogy. Tools like Terraform define your entire infrastructure in code. It ensures your development environment is an exact replica of your production one.
Because that consistency is the only way you can fight configuration drift.
And configuration drift is the ultimate security risk. It's that one-off manual change someone makes in an emergency that suddenly makes your live environment different from your secure, tested baseline.
So you need automated tools to find that drift and fix it instantly.
It's essential. So the final takeaway here is pretty clear. The cloud gives you incredible agility and scale, which you need for things like AI and big data, but that agility is a double-edged sword.
It really is.
That speed is only sustainable if you invest just as much in automation and strict configuration management. The speed at which you can scale up is matched perfectly by the speed at which you can introduce a catastrophic security flaw.
Which brings us to a final provocative thought. We talked about predictive scaling, using historical data to add capacity before a spike happens.
A proactive approach?
So if we can do that for performance, why aren't we applying the same thinking to security?
That's the next frontier. It's not just reacting to configuration drift after it happens. It's about using analytics to anticipate it, to flag a deployment that, based on past patterns, is highly likely to introduce a vulnerability before it ever even goes live. That's the true marriage of operations and security.
Thanks for listening. We will continue to talk about security and technology. See you in the next episode.